The human mind has always had a fascination with worlds beyond our own. Following the stars across the seas, early explorers imagined that they might meet weird creatures in undiscovered lands. They never guessed that under their keels, drifting in the same currents that carried their ships, were life forms far stranger than anything they could imagine. It's a world where the forces of pressure and darkness have given rise to creatures as different as on another planet. Their whole existence is shaped by the great ocean currents, which sweep them endlessly around the biggest living space in the solar system. At the edge of this alien world, here in Florida, one ocean drifter comes from the beach itself. It can take these hatchlings 3 days to claw their way up from nests buried 2 feet deep. They may look like land animals now, but sea turtles have evolved for 80 million years to be riders of the ocean currents. These loggerhead turtles, no larger than a child's hand, are about to embark on a perilous 10-year journey around the ocean. As they head down the beach, they're already reading the Earth's magnetic field with their internal compass. Only one hatchling in 1,000 will survive to adulthood and ride the currents back to this beach to breed. It's among the most extraordinary odysseys in nature. This is the story of one loggerhead's journey into the unknown world of the ocean drifters. Like a wind-up toy, the hatchling swims relentlessly out into the ocean. The waves tell her which way to go, away from shore and from predators stalking the shallow water. Danger causes her to tuck in her limbs, disguising herself as floating debris. Shark doesn't see her and swims on. As she heads towards the safety of deep water, the hatchling joins a rich tide of other marine creatures. Every rock and weed is home to a different species. coastal waters are the fertile breeding ground for the oceans. Florida may produce 5 million loggerhead hatchlings each year. In some coastal species, 500 million offspring may come from a single female. The eggs of this sea urchin and the smoky clouds of sperm from a nearby male swirl together in a fertility dance on the ocean floor. Huge quantities of eggs and larvae produced along the coastline will be drawn out into the ocean currents. Most will become food for other marine creatures. Setting their offspring adrift might not sound like good parental care, but it's a valuable survival mechanism for many coastal species. It lets them populate new areas and encourages the exchange of genetic material. All through the night, instinct drives the loggerhead to push on. The outpouring of new life on the continental shelf below her is just as persistent. With the bellows-like action of her pleopods, the spiny lobster sends 700,000 hatchlings seaward. It's a reproductive blizzard. The lobster's larvae have evolved a flattened shape. It suits them for the drifting life as ideally as a snowflake. After 36 hours of swimming, the hatchling is growing tired. In the clear water 30 miles off the Florida coast, she reaches the edge of the Gulf Stream and finds shelter in the drift lines of sargassum weed. This plant spends its whole life floating on the open sea, held up by small air bladders. The sargassum provides a haven in the vast, featureless world. All kinds of creatures find harbor here. For the first time in her life, the loggerhead can rest. But the stillness is an illusion. The winds have piled up the sargassum weed in drift lines along the edge of one of the most powerful currents in the world. Just beyond, the Gulf Stream hurtles by. Viewed from space, the Earth is alive with clouds caught up in the rhythm of the trade winds. These winds and the rotation of the planet generate the great ocean currents. The loggerhead will be traveling for years in a circle of currents called the North Atlantic Gyre. Her journey starts off Florida in the warm waters of the Gulf Stream, which will carry her north past Cape Cod. Satellite imagery is teaching us that the Gulf Stream is a wild, living carousel, spinning off side currents and stirring up a broth of marine life. The edges of currents are the great way stations of the open sea. Plant and animal drifters are drawn into these fronts, one species making life possible for another. For a hungry animal, it's an oasis in an oceanic desert. The sargassum becomes a perch for goose barnacles. They glean food particles from the plankton, the rich soup of plants and animals, many of them microscopic. Even sluggish homebodies can be marvelously adapted for travel in the larval stage. This glorious creature drifting on wing-like lobes is a snail. Some snail larvae use tentacle-like arms for feeding and to keep from sinking. Some may be able to remain in this stage for months until they drift to a suitable habitat. Everything is kept lightweight for easier travel. Look closely, and you can see the spiral of a transparent shell. These beautiful drifters move so gracefully, you forget that the Gulf Stream is hurrying them along at 100 miles a day. Microscopic larvae spawned in Florida could eventually settle on the shores of Africa, and the next generation may ride the currents back. The ocean drifters have little to eat, except each other, which they do, eagerly. So, if the sargassum weed provides shelter, it also harbors death in an astounding diversity of forms, often wonderfully camouflaged. The seahorse has evolved a mild and plant-like demeanor, but it's still a predator and keenly watchful. It drops down to ambush its planktonic prey. Then loops itself back into the sargassum to avoid being ambushed itself. The entire food chain is caught up in this dangerous game of deception and self-defense. Small fern-like animals known as hydroids colonize the sargassum and feed on the most minute plankton. A sea slug grazes in turn on hydroids. The slug's camouflage doesn't fool a potential predator, but the sea slug has armed itself with chemical defenses from its prey. The filefish abandons the attack, but another creature's camouflage will soon bring the fish to a gory end. The drifting weed may look innocuous, but look again. A fish, hoping to harvest hydroids from this leafy growth, would find itself staring into a malignant eye. Evolution has made the 4-inch-long sargassum fish the big bad wolf of this floating world. Its extraordinary camouflage doesn't just mimic the coloration of the plant. The white spots also mimic the tube worms and hydroids that grow on sargassum. Its pectoral fins have evolved into prehensile fingers, the better to creep through the foliage. It will eat creatures almost its own size, and its victims thrash around in its gut momentarily before they die. The loggerhead swims directly under this hidden peril. But the sargassum fish lets her pass by. Hungry dolphinfish won't be so particular. These big, fast-moving fish can devour all life on the weed lines. The turtle scrambles for a hiding place. Now, the loggerhead pushes on to deeper water. Beyond the sargassum in the open sea, gelatinous drifters are the most abundant life form. They may be the loggerhead's main source of food for much of her journey. A jellyfish like this may be more than 95% water, but the thin membrane of living tissue is still nutritious. We know almost nothing about how the turtle or any other animal survives here. We act as if this is our planet, and we call it Earth. But the oceans are so large and so deep that they constitute more than 99% of the inhabitable world. Even for oceanographers, the open sea is an alien environment, tantalizing and yet largely unexplored. Each creature in the currents has its own story to tell, its own extraordinary adaptations to life on the open sea. Humans venturing into these waters with scuba gear study only the upper layers of the ocean. They stay tethered to a rope like astronauts walking in space. It's a 500-mile swim to shore. Richard Harbison and his colleague Larry Maiden are among the few researchers studying how these ocean drifters behave in their own environment. The air tanks limit them to 25 minutes per dive, so they get just a glimpse of how these high sea drifters really live. Harbison and Maiden specialize in creatures of incredible delicacy, known as jelly plankton. This underwater world changes by the hour. Many species stay away from the brightly lit surface by day, so these researchers dive round the clock. Under the cover of darkness, a whole new world of creatures rises from the depths. It is the largest animal migration on the planet, and it happens every night in the oceans. This sea snail joins a glorious host of species as they ascend to feed at the surface. Life as a jelly is an ingenious adaptation. There are no hard surfaces to run into on the open sea, so these drifters don't need a sturdy body. The gelatinous form gives them the same buoyancy as the water around them. They've evolved for life at sea by becoming organized seawater themselves. Near the surface, the smaller drifters feed on minute plant life that's been growing all day in the sun. Bigger animals come up to feed on them. The great oceanic food chain begins here, and everything else depends on it. This weird apparition is a killing machine for small crustaceans. The writhing arms of this comb jelly startle its victims, which flee straight into the wing-like feeding lobes at either end and become entangled. It's easy to become mesmerized by the delicate structures of some ghostly creature turning gently in the currents. You can see the beating of the heart through the transparent shell. Its mouth parts are like an Easter lily. Ocean conditions have reshaped it beyond all our notions of what a snail should be. Look in another direction, and there's a salp chain grazing on small plant particles. This jelly can reproduce with extraordinary speed to take immediate advantage of a new food source. The salp sprouts new individuals like a chain of paper dolls. The gelatinous form makes for efficient feeding. It allows this siphonophore to spin out lengthy tentacles like fishing lines. It twitches its crustacean-like lures to entice its prey. In the boundless world of mid-ocean, with the sea bottom miles below and no other surfaces nearby, a jelly is the only niche for other species. One animal's body can become the whole world for another. A crustacean deposits her offspring on a comb jelly. As they grow, they devour their host. Crustaceans eat jellies, and jellies eat crustaceans. It's a banquet where it's difficult to distinguish the guests from the dinner. The jellies also prey on one another. The jelly plankton even have their own great white shark. The 3-inch long Baroe is a jelly with jaws. Its mouth is lined with sharp, tooth-like hooks. The Baroe latches onto its prey and then expands to engulf it. This ability to stretch is another advantage of the gelatinous form. Though scuba researchers are limited to working in the upper layers of the ocean, with this submersible, an oceanographer can study drifting life forms down to 3,000 feet. There, the world of the ocean drifters becomes even more fantastic.
Okay, on the surface we're trimmed out. Depth is 330 feet. Temperature is 4 degrees. Visibility is probably 15 to 20.
Edith Witter studies creatures living in the deep sea currents. Her pilot maneuvers skillfully as he collects samples with a battery of scientific equipment. On the way down, they may be the first humans to see creatures that have drifted here for millions of years. Endlessly strange and wonderful. A siphonophore spirals out into the watery darkness like a galaxy. It's maximizing the feeding area for its fringe of stinging tentacles. Scientists have only recently discovered this football-sized comb jelly. They call it Big Red. This fish isn't sick. In these dark, unbounded depths with no top and no bottom, everything simply behaves differently. Like this squid, suspended in the stillness. Or this squid, which has developed a transparent, gelatinous body. All the rules are different down here. Researchers freely admit that what they know about almost any of these animals is less than a paragraph. Scientists have given this newly discovered deep-sea octopus the nickname Dumbo. Witter specializes in bioluminescence, the ability of living creatures to communicate by producing light. To study this phenomenon, she measures what happens when bioluminescent animals drift into this screen. She must shut down her own floodlights and use special cameras to see how they respond. The pitch blackness of deep water suddenly explodes in a fiery light show. A sea cucumber looks strange enough just before it makes contact with the screen. Then it turns on its own lights and rolls off unharmed. Almost every animal uses bioluminescence in the pitch dark of the deep. Given the abundance of life in the oceans, this may be the most common form of communication on Earth. The clouds of bioluminescence can be so bright that they light up the instruments inside the submersible. If attacked, some animals try to confuse their predator with sheer incandescence, like a flashbulb in the face. Others illuminate the predator in the hope that some larger predator will come along like a cop and take it away. Some use light like a lure to draw their prey closer or to attract a mate. In this world of darkness, the language of light is so important that a moment's flickering may determine whether an animal lives or dies. But what we know about bioluminescence is limited by the difficulties of ocean research. Even a submersible stays underwater for only about 3 hours. promise of oceanography is tantalizing. Bioluminescent chemicals are already being used in medicine, but reaping the potential benefits is dangerous work. In many ways, it's like the grand adventure of space travel. But we've mapped the barren surface of Venus in far more detail than our own deep ocean floor. Is it worth exploring the depths of this planet? In one area the size of a small living room, deep-sea researchers recently discovered 460 new species. Who knows what secrets we have yet to discover in the oceans? Even back on the surface, the limits of our knowledge can be painfully apparent. In the complex ecosystem at the very skin of the ocean, a whole other world of creatures lives both in and out of the water. As it moves, the stinging tentacles of the Portuguese man-o-war stream out to gather food. By raising its gas-filled sail, the man-o-war can travel at varying angles to the wind. It's an elegant system for dispersing animals, not just where the current takes them, but across the face of the ocean. Nothing about the man-o-war is simple. It's neither an individual animal nor a colony, but something in between. Joined together under the gas bladder is a kind of cooperative assembly of stomachs, tentacles, and reproductive organs. Other species add to the complexity. One fish called Nomius hides out among the deadly veil of tentacles. The man-o-war's toxin is more potent than the cobra's. But perhaps because of a protective mucus layer or greater immune resistance, Nomius can dine unharmed on the man-o-war itself. Other fish aren't so lucky. The man-o-war can stretch its tentacles out more than 50 feet, and each tentacle is studded with batteries of stinging cells. Nomius may help out the man-o-war by herding these fish toward their death. Triggered by the fish, the stinging cells fire slender threads lined with barbs. The victim is lassoed, hog-tied, and injected with paralyzing poison. Then the digestive organs move in, like some monstrous life form. They wriggle and twist as they fasten their flexible mouths onto the victim. Gradually, they engulf the fish and dissolve its flesh. After half a year, the young loggerhead's odyssey has taken her to mid-ocean. But she still has a lot to learn. All the activity around the man-o-war catches her eye. She just wants to grab a few fishy tidbits and doesn't seem to notice the nasty business overhead. For a moment, the turtle looks like a puppet on a deadly set of strings. But it's the man-o-war that's in danger. The turtle turns her hungry eye on this intriguing new possibility. People talk about the first brave human who ate an oyster, but what a tangled and spicy meal the man-o-war must make. The turtle's skin may be too thick for the stingers to penetrate, but no one knows what protects the turtle's eyes and mouth. The loggerhead soon pushes on, in search of a meal that's not quite so challenging. One of the strangest inhabitants of the harsh world between air and water is the drifting nudibranch named Glaucus. This upside-down sea slug swallows air bubbles to hold itself at the surface. With its pointy appendages, it latches onto anything it's lucky enough to bump into. But what it's really after are the deadly tentacles of the man-o-war. It coats its mouth parts with a mucus layer to protect itself. The smaller, less powerful stinging cells get digested, but the most virulent stingers remain intact. Amazingly, they pass directly to the nudibranch's extremities, and it uses them for its own defense. But these surface drifters must face adversaries even more formidable than each other. A storm is brooding up across the water. It's a reminder of how unstable life must be on the very face of the ocean. One moment, these creatures are being scorched by sun and wind, and the next, they're tumbling in storm-tossed waves. As the storm passes, they get pelted by icy rain and have to endure the dilution of their salty home. Yet the animals living in the ever-changing surface can seem so delicate. This drifting snail builds a fragile home of air bubbles, sealed in an envelope of mucus, then hangs on for dear life. If it lets go, it'll sink into the abyss. The raft is also holding up the snail's offspring in these egg capsules. It's a cradle at the top of a hostile world. When it's done laying eggs, the snail builds a new raft for itself and cuts its 50,000 offspring adrift. Natural debris also drifts in the surface currents. It's always been a means of dispersal for some plants. A coconut from the Caribbean may ride the Atlantic currents thousands of miles to take root on some distant shore. Fish are drawn to this kind of flotsam for shelter. A drifting crate can turn into a small ecosystem where fish lay eggs or find their food. But the little things we throw away add up, and the supply of garbage begins to seem endless. One study estimated that 13 tons of trash per minute was being heaved overboard by ocean-going vessels alone. A recent treaty now regulates the practice, but it's rarely enforced. Whatever goes into the ocean gets drawn into the currents, and it builds up in the very places where marine life is richest. Animals encrusted on debris may rouse the loggerhead's hunger and curiosity. For her, drifting objects have always been a natural food source. Until recently, a loggerhead could safely eat almost anything she came across. Nothing in her evolution has prepared her for this wealth of deadly new choices. It makes as much sense to pick at the festive remnants of a balloon as at a man of war. Fragments like these can choke turtles to death. Plastic blocks their digestive tracts and causes starvation. This time, she's unable to tear off a bite, but she'll face many more opportunities as she swims on. Almost every dead turtle found has plastic in its gut. Millions of seabirds also die each year because of garbage. Like this gannet, tangled up in debris, absent-mindedly discarded by sports fishermen. Commercial fishermen lose thousands of miles of net each year, which spread out all across the oceans like a deadly web. There may be no way for the loggerhead to learn about these new perils until it's too late. The turtle has survived her first year, but in the long seasons before she circles home to Florida to lay her eggs, a more sinister peril may threaten her. Everything out here is absorbing a swelling tide of chemical wastes. Even the plankton. Though they may seem insignificant, the life forms here are important to cloud formation. They even help regulate the global climate. These microscopic plants and animals have always struggled against enormous odds to reach maturity. Now they must also absorb heavy metals, sewage, pesticides, and petrochemicals. Plankton is the base of the food chain, and every marine animal depends on it. If our carelessness disrupts this vast, drifting tide of life, will it imperil the entire ocean? Will it affect the food we eat and the very air we breathe? No one has yet spent enough time traveling in the loggerhead's world to find out. It may be that we humans will always find it easier to turn our imaginations away from the oceans and out to other worlds. But as we peer up at the stars, we should keep one truth in mind. All the alien life forms we know, and perhaps all we ever will know, are here, adrift on planet Earth.